Hi everyone. So in this video we would be covering isolation anomalies and levels. So these are the isolation anomalies. Basically they are the problems which generally happens when multiple transactions occur simultaneously. Alright. And we would also see how to prevent those problems. So those problems can be prevented with these three isolation levels. So we'll discuss about them as well. So let's get started. Now let's start with the dirty read problem. So assume that there are two people who belongs to the same family and they are using the same bank account. All right. And currently they have $1,000 into the bank and they are trying to basically purchase some product at the same time. Right. So TX1 will first try to read balance which is available in the bank account. Right. So it will get the answer as 1,000. Then it will try to purchase some product. Let's say the product cost $500. So we would update the bank balance by like we would do 1,000 minus 500. So the balance would become 500. All right. Now this TX2 will also try to read the balance. Now it gets the answer as 500. Right. Then let's continue first. So over here, this TX1, instead of committing, it got aborted due to some reason, right? Something over here got failed and because of that, this transaction 1 got aborted. So in that case, we have to roll back. If you have seen my previous video, then you might be knowing that if a transaction fails before commit, then we roll back all the changes. So this bank balance will again go back to 1,000, right? But the problem over here is this TX2 already read this value which was not yet committed, isn't it? Now, if this TX2 tries to do something using this 500, then obviously we would have inconsistency in the database, right? For example, let's say it tries to buy a product of $200. So the remaining would be 300, right? Now, if we commit this 300 into the balance would become 300, but in reality it should have been 800, right? So that's the dirty read problem. This transaction read a value which was not yet committed by transaction TX1, and because of that we faced inconsistency like this. Okay, now let's see what is a non-repeatable read problem. So over here, let's assume that we are dealing with some kind of e-commerce application wherein you can find an iPhone for $800, right? And this transaction 1 is basically trying to purchase that iPhone, and this transaction 2 is, let's say, initiated by admin, wherein admin is trying to update the price of the iPhone from $800 to $700. All right. So now let's try to execute these steps one by one. So once this transaction is initiated, it will first try to read the price of the iPhone, which is 800. All right. After that, it will start the payment process. So while this payment was being processed, this TX2 updates the price of the iPhone from $800 to $700, and it also committed the changes. All right. So now the iPhone will become $700. All right. So now at this point of time, if transaction 1 reads the price of the iPhone again, it will get to know that it is $700. Okay. So that's the non-repeatable read problem, wherein you are trying to read the same row multiple times, but you are getting the different answer. First time you got $800, second time you got $700. All right. So this is the problem, and the impact of this problem is, let's say you are going to generate the invoice over here. So if you generate the invoice at that point of time, so that time you would see that the iPhone is of $700. So in the invoice you would write $700, isn't it? So you paid $800, but on invoice you got $700. Now let's assume that you try to return that iPhone due to some reason. Maybe you didn't like that iPhone. So in that case, you will not get $800. You will just get $700 because on the invoice, you have $700, right? So this is the impact. But the problem is this: when you try to read same row multiple times, then it is giving you different value. This is the problem. All right. So I hope you got the problem and the impact. Now let's try to understand what is the phantom read problem. So assume that there is a meeting room which only allows 5 meetings to be scheduled in one single day, right? So both of the transactions are trying to schedule the meeting. All right. So they will first try to know how many meetings are already scheduled on a specific day. So assume that the database gives you 4 rows. Okay, 4 rows means 4 meetings are already scheduled on the specific day, right? And at the same time, transaction 2 also asks the same question to the database, and the database says that there are 4 meetings already scheduled on the specific day. So transaction 2 sees that, okay, there are only 4 meetings scheduled and we can schedule total of 5 meetings in a day. So let's schedule one more meeting. Okay, so this transaction 2 schedules that meeting. Basically, it inserts that row, new row, into the database. Okay, and it also commits that changes, right? Now, if transaction 1 again perform the same query, right, then it will get different number of rows. Earlier, it got 4 rows because 4 meetings were scheduled. Now it got 5 rows because transaction 2 scheduled one more meeting between this reads, right? So this is what a phantom read is. When you try to execute the same query multiple times, you'd get different sets of row. First time you got 4 rows, second time you got 5 rows. All right. This happens because there might be another transaction which might either delete or insert a new row. Okay. And the impact is quite clear. That is, instead of reading, if let's say you proceeded to book the event, okay, that is you try to insert one more event over here, or you try to schedule one more event because you thought that only 4 events were there, then in that case, obviously we would be having we would violate the business constraint, right? According to business, one room can only have 5 meetings, but now that room has total of 6 meetings, right? So this problem happened because of phantom read problem. Okay, and there's a subtle difference between phantom read problem and you can say non-repeatable read problem. In non-repeatable read, we are reading the same row multiple times and that is giving us the different value. Whereas over here, we are executing the same query multiple times and it is giving us different sets of row. First time it gives 4 rows. Second time it might give you, let's say, 3 rows or 7 rows or whatnot. But it is giving you different sets of rows. Okay. So this is the phantom read problem. I hope you got this problem. Now let's see what is the lost update problem. So assume that we are dealing with some movie booking application wherein there are total of 10 seats available for a specific show. Okay. And there are 2 people who are trying to book the seats at the same time. Okay. So first of all, what they will do is in transaction 1, we would first ask whether how many seats are available. So transaction 1 will get to know that there are 10 seats available. At the same time, transaction 2 will also ask the same question, how many seats are available. So it will also get the same answer, which is 10. Now assume that this transaction 2 is being initiated by a person who is also trying to book the seats for his friends as well. So total they are trying to book 5 seats because they are 5 friends. So 10 minus 5 will become 5. Okay, and this transaction 2 is also committing the changes. So this seats would become 5. All right. Now this transaction 1 will try to book 2 seats out of 10 seats, which it read over here, right? It read that there were 10 seats available. So it will now try to reduce 10 by 2. Okay. So assume that this transaction 1 is being initiated by a person who is trying to book this seat for himself and his wife. So 10 minus 2 is 8. Okay. So after that, he will try to commit that changes. So now this 8 will be reflected over here. All right. So I hope you noticed the problem. The problem is the update made by transaction 2 got lost, right? So this is the lost update problem. Now let's see what is this write skew problem. So assume that we are dealing with some kind of hospital system wherein there is a constraint that at least 2 doctors should be on call. All right. And also assume that LS and Bob wants to apply for a leave and they try to apply for a leave simultaneously at the same time. All right. So first this transaction will try to check how many doctors are currently on call. Okay, so it will get to know that 3 doctors are currently on call. And at the same time, transaction 2 will also try to check the same thing, and it will also get the same result, which is 3 doctors are currently on call. So this transaction 1 will think that, okay, there are 3 doctors currently on call, and if I try to apply for a leave, then also this condition will be satisfied, right? So transaction 1 will basically mark LS as off call, and transaction 2 will also think that there are 3 doctors who are currently on call. So if Bob wants to go off call, then also it's okay because this condition is satisfied, right? Now if transaction 2 commits these changes, then in that case Bob will become off call, and after transaction 1 commits itself, then LS will also become off call. Right. So at the end of the day, we have violated this business constraint, which says that at least 2 doctors should be on call. But now we have only 1 doctor on call, isn't it? So this is the write skew problem. This problem occurs when multiple transactions are executed simultaneously and they both are trying to update different rows. Transaction 1 is trying to update the row corresponding to LS, whereas Bob is trying to update the row corresponding to Bob. So I hope now you are clear with this write skew problem. Now that we have seen all the isolation anomalies which occur when multiple transactions run concurrently, let's try to understand how do we prevent them. So as an engineer, you don't have to write any code. Okay, you just have to select one of this isolation level. For example, if I select read committed isolation level, then database will prevent dirty read problem. You would never face dirty read problem if you select read committed isolation level. Now how to select read committed isolation level? It's very simple. Before starting the transaction, you can set the transaction isolation level as read committed. If you want to prevent all these problems, then you need to just select isolation level as repeatable read. So here you have to write repeatable read. Okay. And if you want to prevent everything, then just select serializable. Okay. Now, by the way, there is a trade-off of selecting this isolation level. If you select isolation level as serializable, then in that case, the performance will degrade, but you would basically prevent all the problems. And if you try to select isolation level as read committed, then the performance will be very good, but you would not be able to prevent all the problems which I have mentioned over here, like non-repeatable read, phantom read, etc. All right. So this is the trade-off. And by the way, this data is valid for the Postgres database. It might differ for other databases. Okay. So you just need to check what isolation level will prevent what problems for your own database. I have written this because I know about Postgres. Okay. Now let me ask you one of the interview question. The question is, what isolation level will you use for a movie booking application like Book My Show? The answer is, since we have to prevent lost update and dirty read problems, right? In movie booking application, we don't want dirty read and lost update problems. So since we have to prevent those, we would be selecting either repeatable read or serializable. But as we already discussed, if we go downwards, then the performance will degrade, right? If we select serializable, then the performance will degrade. Hence, out of these two, I would be selecting repeatable read isolation level, right? Because both of them will do the job which I want them to do, that is prevent loss update and dirty read. But this has a greater performance compared to serializable. Okay, so this should be your answer in the interview. So with this, I hope now you understood all the problems which can occur when multiple transactions run concurrently. And I also hope that you understood the different isolation levels which are used to prevent these problems. So if you found this video helpful, then please hit the like button so that this video can reach to more and more people. Thanks for watching.